Hey, Caitlin. Oh. Hey, Caitlin.
Hello,
How you doing?
I'm good. How are you doing? How are you feeling?
Doing peachy keen wonderful.
Good.
Let's just say there are areas of my body that had things done to them that shouldn't have had done to them.
That sounds like a reasonable summary.
Yeah, well, what can I say? It's all done now, and basically we're just going to get on from here now.
All right,
Worst is over.
that's good.
Anything I can do for you, Caitlin?
I do have a question. There was one question I missed on the quiz that's due now. Is it too
Okay.
soon to ask about it?
Go for it.
It was, I wrote it down. How many moles is 24.13 grams of magnesium chloride?
How many moles to 24.13 moles of magnesium chloride?
Yeah,
Okay.
MgCl2.
All right. To do this, you want moles, right?
Yep.
Okay. So moles is going to have to be on top and grams is going to have to be on the bottom, right, Kaylin?
Yep. Yes.
So magnesium is 24.31, right?
Mm-hmm.
2 chlorines are 35.45 times 2.
Yep.
I always worry when this happens because when you're that confident, this means I made a mistake.
So far, it seems like what I wrote.
Okay, so I got 25.21 for the grams.
Yeah, so did I.
Okay, so I got 24.13 divided by 95.21. I got 0.2534.
So did I.
And what was the answer?
1.
Okay, let's see. Okay, let's see where. Okay, Aya, you there? Aya?
Here,
Hi, how you doing?
I'm good.
That's not what I want. Oh, crap. Okay, crap. Okay, damn it. Oh, good. I'm in the right place. I am in the right place. Okay, I'm just looking up a question, Aya, okay?
Okay.
It seems as though Kaylin and I came up with the right answer, but the quiz has the wrong answer. And is it quiz 11?
Quiz 11, yes.
And which question was it?
Number 5, I think. The last
Okay.
one.
The last one?
The last question, yes.
Okay. Nope. Quiz 11, right? Or quiz 12?
I haven't taken 12 yet.
Okay, I'm looking at quiz 11 and quiz 11 has 10 questions.
Okay, well then question 10. That one.
Yeah.
I got that one right only because I guessed.
Well then, I have no idea. I have no idea what I did there.
Okay.
Absolutely no
well, I
idea.
feel better. I couldn't figure out what I missed because I was looking back at other questions that were exactly the same, but
No, you got it right. I got it
Okay.
wrong. So obviously I'm going to have to go back and fix it. Aya, do you have any questions? Since Kaylin is intent on making me look like a fool. Aya, do you have any questions?
Not really. I do want to know, like, if you did add my extra credit for the first one, but
The first one?
yeah, I didn't submit it in the box on time, but I sent you an email and you said you'll count it.
Okay, and extra credit on the test?
I think it was the first extra credit ever. Give me 1 second. I'll pop it up.
Okay, now I need to edit that. Okay. Aya, anything?
Just give me a second. It's just loading.
Okay. No problem.
Hey, Professor.
Hi, Andrew. How
Hey,
you doing? Hunter, how you doing?
I'm all right. Bit tired. Did you already have your surgery?
Yeah, I did.
How are you feeling?
Sore? I'm doing fine
Yeah.
though. Doing
When
fine.
was that? A couple days ago?
Wednesday, last Wednesday.
Oh, okay.
So yeah, doing good, doing good. Just, you would not believe the bruises on my stomach.
The what?
You wouldn't believe the bruises on my stomach. It looks like Muhammad Ali just did a
Oh
round
my
on
God.
it.
Mike Tyson just,
Yeah, just had to go at it.
oh my gosh.
Okay.
It'll
got
heal.
that. Eventually, or
Yeah.
not.
It's the extra credit quiz.
Extra credit quiz.
Yes.
All right, I'm in here.
Dude, I need to get a tan on my head.
I'm looking at the extra credits, but I'm not seeing any quiz. I'm looking at the quizzes. I'm not seeing any extra credit. Are you sure it wasn't a Dropbox, Aya?
Um,
Because if I'm looking at
I
Drop, I
think
gotta,
I think it is a Dropbox, but
okay,
it's a
well,
quiz.
that's, I'm sorry, what?
Yeah, I think it's a Dropbox, but
Okay.
it's called extra credit quiz. Up to 4 points extra bonus.
Okay. I'm not seeing anything submitted for you.
I think I submitted it on the email and you said you'll count it. Just let me pop up the email. 1 sec.
Okay. Hunter, anything you got a question on?
Yeah, and I have a bunch of questions, but not necessarily pertaining to the chemistry stuff right now.
Okay. Good enough.
Oh, I think I saw something interesting, but keep it to myself right now. I'm sure people have like real things to talk about.
Okay, quiz 11. Okay, if you guys don't have anything, I'm gonna be grading quiz 11s.
I have the email. I just don't know how to show it to you.
Okay. When was it? Aya?
On Friday, February 12th.
Okay, let me get back here. So I'm looking for it, Aya. And how many points was that worth? Do you remember?
Think 4.
Sorry, I'm working my way back here. Okay, the nice news to you, Haya, is I do have it.
Yay.
You want to hear something cool, Professor?
What's going on, Hunter? Tell me.
I was reading an article a couple of days ago about like scientific things in 2021, and they're saying that they like long predicted that the first molecule was helium hydride, like HEH plus,
Okay.
and I guess they got some sort of new evidence that that was in fact the first molecule in the early universe.
That doesn't surprise me. That was the first molecule. No, I can't. No, I don't buy that. I believe H2 was the first one. First molecule.
Well, that's just what these articles were saying.
Okay. Okay, Aya.
Yes.
Okay. All right, are you looking at the email yourself, Aya?
Yeah.
All right. Now I'm looking at this. Okay. So where are you equating? Where are you equating the density of the boat with the added pennies to the density of water? Because that's what it's going to take, Aya. You have to change over the density of the boat has to be greater than the density of water for it to sink. Do you believe that, Aya?
Yes.
Okay, so where in here are you ever talking about densities?
See, I don't have the extra credit popped up, but I have the email, so I don't know what you're looking at, but
I'm looking at your email. I'm looking at your answer for your email.
let me see.
Anybody have anything else? I keep on working at it, okay?
Okay, thank you.
Aya,
Yes.
part of the confusion is that ounces can be either a weight or it can be a volume. Do you understand that, Aya?
Yes.
Okay, so the ounces that are listed as the boat weight, that is weight. Okay, you can't convert the ounces that you convert the cups to are liquid ounces. They're not mass ounces. Does that make sense to you, Aya?
Oh, yeah.
All right, so what you were supposed to do in this problem, you were supposed to take the ounces, convert that to grams. And you're supposed to take the cups and convert that to milliliters. Then you divide the grams by the milliliters. That gives you the density of the boat, okay? But the density of the boat increases when you add weight to it. So when you add the pennies, each penny is going to add more weight to that boat. And you just had to figure out how many pennies it took to sink to increase the density to more than 1 gram per milliliter. Okay, Aya?
Yeah, that makes more sense.
I'm sorry. Looking at this, I can't give you any credit for it.
It's fine. It's fine.
Okay. I don't want to do that. I want to do that. Okay, anything else? Who else is in here? Faith, I saw you in here. How are you doing, Faith?
I'm good.
Fine as kind. Chase is in. My screen sharing is paused. Why is my screen sharing paused? Thank you. Share screen. Oh, nobody wants to talk tonight. You want to see my bruises?
How did your surgery go?
It went fine. Went real good.
That's good.
I basically, it was only the extraneous stuff that was a bit of a problem. If you ever go to have abdominal surgery, you have to understand that what they do is they pump your body full of air, and it makes things very painful afterwards.
Mhm.
So that was one of the things. And then there were other less conversational things that were happening. So I've been doing fine, guys. I'm 3 walks a day, each one a half an hour. So I'm doing great. And I'm here. Aren't you glad? If I wasn't here, Lord God, what would happen to you all? Hi, Mila.
Hello. I hope you're feeling good. We were thinking about you.
Thank you very much, Mila. I'm doing okay.
I don't know what he's trying to say. He wants to go to Dinosaur World at Disney.
There you go. I want to go to Dinosaur World at Disney. You take me too?
They have the T-Rex cafe there. It's like it's like the rainforest cafe, but it's all like prehistoric. It's actually really cool.
Fine as kind. I used to live in Pittsburgh, and the Carnegie Museum there had some of the original fossils that they pulled out of Montana and I think it's North Dakota. And we actually had a T-Rex, full fossilized, full-scale T-Rex.
Oh, that's awesome.
Yeah, it really was awesome.
Yeah.
So I take it we're in the dinosaur age now, huh?
Oh, everything dinosaur. We're about to redo their bedrooms for his second birthday, and it's going to be all dinosaurs.
Absolutely great. Do not show them Jurassic Park though.
They have kid ones now that's like cartoon and stuff.
No, that one you can show, but the actual Jurassic Park I think is.
Oh, it's way too scary.
Yeah.
And then on YouTube they have a whole Jurassic like series that just is like computer profiles of different dinosaurs. It says like what they eat, what they do, like when they lived and stuff.
That's dynamite, absolutely dynamite. Okay, guys, it's getting about time. Anybody have any questions? Anything other than the fact that you have a question? What is your question? At least he knows to raise his hand, Mila.
I have a question about the pop quiz.
The pop quiz, have you looked at it yet?
No, I wanted to ask what would be covered in it.
Everything and everything.
Oh, great.
Have faith.
How many questions is it?
10.
Oh.
Short answers. I expect a full paragraph on each.
Oh no.
Oh, and I grade on grammar. Anybody else have any questions? Oh, I got 4 minutes to tap dance away here, guys. Anybody have any trouble with the lab?
It was kind of confusing, but I think I got it.
Was it all multiple choice or were there any short answers in there? I haven't really looked at it yet. I was supposed to, but I didn't.
I think it was pretty much all multiple choice except for the very first question.
Is that the one
Yeah,
that
but
you
the
don't
multiple
normally?
choice has like 20 different.
I know. Please, in your SCI or SSI, please make a comment on that. Because it gets ridiculous after a while.
No, I'm not. Oh, are you talking about the student survey?
Yeah,
No, I'm not going to say. I don't want to say anything because then, well, your department head will be like, "Oh,
not on me, Andrew or Hunter, not on me. It's not my quiz.
oh, okay."
I don't make those quizzes up. Those are completely made by Dr. Musgrave.
All right.
All right, let's see who's in here. I got 12 people, my peoples. Okay.
Professor, I got in a couple minutes ago. I'm not sure if anyone asked, but how was your spring break?
You know what I was doing on spring break, don't you, Jennifer?
I saw the post, but I didn't know if that lasted the whole spring break or if you did anything else.
Oh yeah, pretty much the whole spring break. From Wednesday last week
Oh.
until now.
He got into a fight with Mike Tyson.
Yeah, it wasn't pretty. My stomach is really bruised, but I'm doing fine. I'm doing absolutely fine. I've been out walking the whole time, walking 3 times a day for 30 minutes. So I'm doing just great. Peachy keen. Thank you
That's
for
good.
asking.
You're welcome. I mean, that's good. You're here, so that's a good, positive.
Absolutely. I do want to bring up a bad point though, guys. I think if I'm not mistaken, the last day to withdraw is coming up. I really haven't looked at anybody's grades, but if anybody wants to talk with me, please feel free to give me a call. I'll be happy to go over your grades and talk and see how we're doing to basically tell you whether or not you should consider it. Okay? I keep on popping people in here. Okay.
Mr. P, can I ask you a question?
Absolutely. That's what we're here
You-
for, Christine.
Only, well, it kind of related, not related. So I'm looking at your Gen Chem for for summer. Do you only teach that at 5:30 or do you have like a morning class that you teach too?
Christina, I'm sorry, but literally, there are skin and bones. As a matter of fact, right now, that may be the only class I'm teaching.
Okay. Well, my job
the-
is just terrible with letting me out on time. Obviously, like I
Well,
just walked through the door.
And
Oh.
that's a 2-hour class.
Yeah,
Okay?
and I'm not opposed to that. I just wanted to take you for it. And I need to be in
Thank you.
class for some things. You know what I mean? Like I want to see things on a whiteboard. I'm just, maybe I'm too old. I don't know.
It is a face-to-face class. I
Yeah.
have agreed to do that. But literally speaking, I'm scrambling right now myself, Christine. I'm
Sure.
asking other people in other campuses whether they have classes.
Okay.
It may be the only class I teach this summer.
Well, you may see my smiling face on Tuesdays and Thursdays at 5:30.
There
Okay.
you go. I'd be happy to have you, Christine.
Awesome. Thank you.
Okay, ladies and gentlemen. Did you have a good break? Did you have a good break, everybody?
Amazing break.
Yes.
I
Yes.
hope you
without a
didn't do
doubt.
anything stupid like study chemistry.
Not a chance.
Fine, would.
Good. That means you're fresh. That means you can start studying now. This next block of instruction, I'm going to have to teach this more or less like it's going to be like a work study type of thing. It's going to be in terms of you're gonna have to come with me, and you're gonna have to learn how to do these. I've tried to organize empirical formula and mass percent problems in a way so that you can kind of recognize them, because you need to recognize them to then go on. They're going to be the hardest problems you have this semester, without a doubt. Okay, everybody here? Let's just look in and see now. I need to find the right place. Omar, you here? Omar? Lewis?
Here.
Christina's here. Gaith? He'll pop in late. Zaina, I saw Curtis. You hear Curtis? Terry?
Yes, sir. I'm here.
Thank you. Thank you, Curtis. Terry? Apple Grace, I saw. Hunter, I saw. Maria? Chase, I saw. Fabiana? Fabiana? Leandre? Neela? Kaylin is obviously here. Aya's here. Elizabeth? Kevin, I saw. Shmira? Mariah?
Here.
Thank you. Aaron?
I'm here.
Rosina? I saw.
Here.
Andrew Melick? Katie? Katie? Cash? Hayden?
Here.
Faith is here. Mila is here. Jennifer is here. Alec?
Here.
Thank you, Alec. Brian is here. Let's see. Leandre just popped in. Helen? Spencer, I saw. Victoria, I saw. Tori, rather. Are we doing okay, guys?
You didn't call my name.
I saw you already, Armethea.
Okay.
Good enough. How we doing, everybody? Doing okay? Peachy keen wonderful? I got about 5 inches of pillows under my butt right now. Everything is fine. So we're turning. Right now, we're determining the simplest formulas for the simplest molecules. That is what an empirical formula is. Now, first 2 slides are going to be the synopsis of how we solve the 2 different problems we're going to have today. We're going to do mass percent problems. The first step, find the masses of each element. Usually, guys, this is going to be the hardest step. The second step, you add up all the masses of all the elements. Third step, you divide the mass of the individual element by the mass of the whole thing. Questions on that? Seems fairly straightforward, guys? Fairly straightforward?
Yes.
Yes.
Okay, again, I'm gonna have this slide. Guys, I'm gonna stop the video on here because I know my face is kind of scrunching at times. Is this okay with you? Am I turning off my video? Is that okay?
Yeah, that's fine.
Yes. Yeah.
Yes.
It's got, thank you. All right. If I'm doing an empirical formula problem, it has very specific steps, just like the mass percent. Again, first step is to find the masses of each element. Okay? Then what you have to do is you have to turn the masses of the elements into moles. Then you've got the moles of each one of the elements that are within the compound. You're going to find the smallest number of moles within it, and you're going to divide each one of the moles of the elements by the smallest one. That is the molar ratio between the atoms. That is the subscripts you put for the empirical formula. When you do that, if you happen to end up with a fraction, you got to multiply it by an integer to get rid of the fraction. And you don't just multiply it by the one that's the fraction, you multiply it by each one of the mole ratios. So let's get started here, guys. These are the individual type of problems we're going to be dealing with. We're going to be dealing with percent composition from given weights, piece of cake. We're going to deal with percent composition from an empirical formula. We're going to deal with a straight up empirical formula calculation. We're going to deal with empirical formulas from reactant compounds. We're going to deal with empirical formulas from percent compositions. And then we're going to determine a molecular formula calculated from the empirical formula. Curtis, do you know the difference between a molecular formula and an empirical formula?
Do not.
Good enough. Thank you very much for being honest. Anybody out there, I'll throw it out to the general public. Anybody know the difference between a molecular formula and an empirical formula? I'm hearing crickets here, so write this down, guys. A molecular formula gives you the exact number of atoms within that molecule. A molecular formula gives you the exact number of atoms within that molecule. An empirical formula is the smallest ratio of atoms in the molecule. And I'll get into that in a little more in a second. But we need to know that there is a definite difference between a molecular formula and an empirical formula.
Can you repeat the empirical one again, please?
An empirical formula is the smallest ratio. I think it's coming up, Mila. Molecular formula, as I showed you, is the formula of the compound that defines the actual number of atoms present within that compound. If I am going for glucose, the actual number of carbons in glucose is 6, so it gets the subscript 6. The smallest number of hydrogens is 12, or the number of actual hydrogens in glucose is 12, so it has a subscript 12. And there are 6 oxygens, so it has a subscript of 6. But if you look at that molecule, can I divide all of those subscripts by a number?
3.
Okay, but can I divide it by, okay, if I divide it by 3, Curtis, I get C2H4O2. Can I divide that by another number? C2H4O2.
Yeah, you should be able to divide that by 3 again.
Now
Should be 6.
2 again.
Yeah.
Okay, so actually I can divide this one by 6. So the smallest ratio of carbons to hydrogens to oxygens within glucose is C1H2O1. The smallest ratio of atoms within the molecule is called the empirical formula. Did you get that, Mila? Mila?
Yeah, so I'm sorry. The 6/18. Wait, where are you going? Okay.
Don't worry about the 6/18.
That's the molecular formula, and then the 1/3 is the empirical. Is that what you're saying?
No.
Just kidding then, no.
Okay. Don't worry about the 6/18 is equal to 1/3. Actually, I don't even know what I was thinking about when I wrote that in there. All right.
Okay. I mean, one's just going to tell you how many atoms are in a molecule. Another's just going to tell you the ratio of the atoms in the molecule.
Basically, Hunter, you got it.
Okay. That's okay.
Hunter, you got it. The molecular formula tells you actual number of atoms within the molecule. The empirical formula tells you the ratio. And I don't understand why. Yeah, empirical formula tells you the ratio. So if I have glucose, C6H12O6, I can divide all the subscripts by 6, and end up with the empirical formula CH2O. The ratio of carbons to hydrogens, there are 2 hydrogens for every carbon. Ratio of hydrogens to oxygens, 2 hydrogens for every oxygen. That makes sense, Mila?
Yeah. Would, I don't know how I'm like trying to ask this. Would you then like make that a ratio also?
It's a ratio right now.
Well, like with the how you had it like as a fraction kind of.
I have a question.
One second, Hunter.
I don't know if that makes sense. I don't really know what I'm trying to ask, honestly.
What
I
you
think I
could-
just need to see more examples. Just ignore that I am even asking a question, please.
What you could do is you could do something like this.
Yeah, that's what I'm trying. Okay.
You could
Yeah.
do that, okay?
what
But
I
you
was-
have to understand, these are ratios of the atoms within a molecule. When you do the ratios like this will give you the subscripts for the
Yeah.
empirical formula. Okay?
That's what I was like getting at. Okay, thank you.
Hunter, your question.
You kind of like half answered it when you put the ratio there, but I was asking if it's C or carbon 6, hydrogen 12, oxygen 6, and we put it as CH2O, then how would we know, like, you know, that the ratio is divided by 6? But you half answered it because
Hunter, you have to be provided more information.
Gotcha. Yeah, that's what I'm.
You
do
have
we
to be
need to know
provided more information.
Okay.
This actually, it could be C2H4O2. It could be C12H24O12. Okay,
Gotcha.
you don't know what the molecular formula is unless you're given more information, and we are going to be doing that later on. Okay. Now, when you convert from one to the other, all the subscripts in an empirical formula are multiplied by an integer. So if you have the molecular formula, find the least common denominator and divide by it. If I have H2O2, least common denominator between both of those subscripts is 2, so I divide H2O2 by 2, I get the empirical formula for hydrogen peroxide is HO. If I have benzene, which is C6H6, least common denominator is 6. Divide both of the subscripts by 6, I get the empirical formula, which is C1H1. On the other hand, if I'm converting from the empirical formula to the molecular formula, what I'm going to do is I'm going to multiply all the subscripts by an integer. So if I have something like sucrose, which, no, sorry, can't do sucrose. If I have something like hexane, which is C6H14. If I have the empirical formula is C3H7. It has to be multiplied by an integer. That integer is 2 to make C6H14. All I'm doing right now is, if you want to go from the molecular formula to the empirical, you have to divide by an integer. If you want to go from the empirical formula to the molecular formula, you have to multiply by an integer. We good with that? That's all this slide is meant to do.
How do you know like what integer to multiply it by?
Hayden, we're going to get into that. Features to come, okay, Hayden?
Okay.
All right, if I have carbon dioxide, each molecule consists of 2 atoms of oxygen, 1 atom of carbon. In the case of carbon dioxide, the empirical formula and molecular formula are the same because I can't divide 1 and 2 by anything but 1, right? So carbon dioxide's molecular and empirical formula are the same. Water, 2 hydrogens, 1 oxygen. Again, I can't divide the subscripts 2 and 1 by anything but 1, so the empirical and the molecular formulas are the same. But if I have hydrogen peroxide, the molecular formula is H2O2. I can divide both of those subscripts by 2. So therefore, if I can, and do that, that means I have the empirical formula of HO. Is there any confusion about this so far, guys? Difference between molecular and empirical formulas.
So when you're writing it, you don't have to put that 2 that you just took out everything. You don't have to write that anywhere.
No.
It's just gone. Okay.
No, it's just gone.
Okay.
If I give you the formula H2O2 and ask you what is the empirical formula of this, the answer to that is HO.
Okay.
If I give you benzene C6H6, the empirical formula for that is CH. Make sense?
Yes.
Again, if I'm dealing with glucose, all those numbers that are subscripts can be divided by 6. So if I do that, I get the empirical formula of CH2O. An empirical formula is the formula with the smallest whole number ratio between the atoms in a compound. The molecular formula is the one with the actual number of each atoms within that molecule. Now, the molar ratio within a compound is determined by its subscript. If I have a molecule of iron 2 chlorate, the formula is Fe parentheses ClO3 in parentheses 2. So I know that each molecule has 1 atom of iron, 2 atoms of chlorine, and 6 atoms of oxygen. Is there anybody that can't see that? All right. What happens if I multiply each one of these numbers by 6.02 times 10 to the 23rd? In that case, don't I have 6.02 e to the 23rd iron atoms and 1.21 e to the 24th chlorine atoms, and I'm sorry, I can't see this last number, 3.61 e to the 24th O atoms. All I've done is multiply the number of the subscript by Avogadro's number. Is that not true, guys? Well, if I multiplied it by 6.02, I can change atoms into moles, can't I? By dividing it by 6.02. So if I have 6.02 e to the 23rd iron atoms, and I multiply that by 1 mole over 6.02 times e to the 23rd atoms, that gives me 1 mole of iron, right? If I have 1.21 e to the 24th times 1 mole over 6.02 times 10 to the 23rd, that's 2 moles of chlorine atoms. So if I have 3.61 e to the 24th O atoms, and I divide that by 1, or multiply that by 1 mole over 6.02, that will give me 6 moles of oxygen. So if I do that, guys, the whole thing I'm trying to show you here, when you look at the subscripts within a compound, that is the molar ratio between the elements within that compound. If you don't like the derivation I just went through, then forget about it and just memorize this concept. Subscripts in a formula equal the molar ratio between the atoms in that compound. This is why, guys, remember, the first thing I told you when you were predicting products is just put them together. Don't carry over the subscripts. This is the reason you can't carry over the subscripts, because if we mix barium chloride with sodium hydroxide, you would think that the subscript 2 just carries over. It doesn't. You've made a whole new compound. Instead of having a 1-to-1 ratio between the sodium and the chlorine, you now have a 1-to-2 ratio. Okay, now we're going to get into the actual problems. And the first couple problems are fairly easy. They're intuitive, and I'm sure that, well, I think you can do it. Christina, you have 11.17 grams of iron. That reacts entirely with 4.8 grams of oxygen. What is the percent of iron in the compound? Can you tell me how to do this problem?
You would add them both together and then divide the 11.17 divided by the total mass.
Simple
Total
enough,
weight.
guys. All we're doing, mass percents, part divided by whole times 100. In this case, I asked for the percent iron. So the part is going to be the weight of the iron, the 11.17. The whole is going to be the weight of the iron and the oxygen. That's going to be the 11.17 plus the 4.18. Think of it like this. I hate to bring in baseball. No, I don't. I love baseball. If a batter gets 99 hits in every 300 at-bats, guys, I'm obviously not talking about a Rays hitter. If a batter gets 99 hits in every 300, this means his total chances were 300, and he was successful 99 times. So 99 is the part, 300 is the whole. I divide the 99 by the 300, and I get the percent success that he has in hitting. So when I'm doing my problem here, I'm looking. The first off, I know immediately from the problem what my part is. My part is going to be my grams of iron. I have to figure out what my whole is. And my whole is going to be iron plus oxygen. I add those two up, I get 15.97. So at this point, all I have to do is figure out my weight of the iron over the weight of the iron and oxygen, multiply it by 100, I get my percentage. Anybody have any questions on this one? Questions, guys?
Professor, just I think
I'll
in
give that
terms of the math, I think it's 69.94%, not
Yeah, that's what I get.
74.95.
Who came up with that first?
Rosina.
Rosina, your last name. You got a point. You got an
Split
extra
with
credit point.
Curtis. I'll split with Curtis. Mardani.
No, we don't give.
You got it, Rosina. You got it. Thank you.
MAR.
MAR? No, she really
DH.
wants this. I'm sorry.
Sorry, MARDHANI.
What are you saying? What are you talking about, Rosina? It's right up on the board right there, 69.94%.
Yeah, I don't know what I was looking at.
Yeah, jeez. All right, another term that is used that you will see around, especially if you're looking at something like a water treatment report. You will see something known as parts per million. All right, what percent means is actually parts per 100. So to change a percentage to a parts per million, you have to multiply the percentage by 10,000. Okay, let's think about this. If you have 0.54%, that is 0.54 divided by 100. That's equal to X over 1 million. So since 1 million divided by 100 is 10,000, if I take the 0.54 and multiply by 10,000 over 10,000, I get 5,400 over 1 million, or 5,400 ppm. Do you understand how to change percentages to ppm?
No, I'm still confused. So if we get 54%, we
Okay.
multiply that by 10,000 over 10,000.
Yeah, okay, Curtis, a ppm, part per million. Since it's per million, there has to be a million on the bottom, right?
Right.
Okay, so if I have 0.54 over 100, in order to get that 100 to 1 million, I have to multiply it by 10,000. Does that make sense, Curtis?
Yeah, I get that. Yeah.
Okay, but I have to multiply it by 1. So I can't multiply it by 1 over 10,000. I have to multiply it by 10,000 over 10,000. Does that make sense, Curtis?
Gotcha. So we would get 5,400 over
1
a
million,
million.
or 5,400 parts per million.
Gotcha. All right, that makes sense.
All right, the other way you can do it, you can simply, if you don't like that, you can do this simple ratio here. Do you see this one right here? You could put 0.54 divided by 100 is equal to X over a million. It'll get you the same answer.
Can you just go back to that slide really quick? I'm sorry. I just
No.
want to copy it down so I have an understanding. Sorry. Someone was at my door as my Terminix guy.
Mila, in order to go from parts per million to parts per, in order to go from percent to parts per million, you have to multiply percent by 10,000. Okay?
Yeah, I think like writing it down, I kind of am understanding it. I think if I actually apply it now, I'll get it.
Okay, we can do mass percents for percentages of different substances within a mixture. You have a salt and sand mixture that is 35.6% salt. If the mixture weighs 35.62 grams, how much is salt? How much is sand? Okay? There are a couple ways you can do this. The first thing, you have to realize that a percentage is only a ratio to 100. So 35.6% is the same as 35.6 over 100, or 0.356. Basically, what you're doing, when you made the percentage, you multiply by 100. To get rid of the percentage sign, you have to divide that percentage by 100. Okay, you can also do it by ratios. If it is 35.6 over 100, or 35.6%, and the total mass you have is 25.62, then you know that 35.6 over 100 is equal to some new number over 25.62. You do the cross multiplication there, and you end up, in this case, X is equal to 9.12 grams. You can also do that by doing a percentage. 35.6% is 0.356. All I have to do is take the 0.356, multiply that by the total weight. That will get me the weight of the sand. Questions on this?
Which way is going to be more beneficial to do?
I think, Mila, you like ratios, don't you?
Yes.
Then do the ratio.
Okay.
It doesn't matter. It's not going to help you either way. One's not faster than the other. I'm just showing you both ways of doing it. Questions, guys? What is the percent composition of iron, sulfur, and oxygen in FeSO4? Oh my God. How am I going to do this? All right. Remember, the subscripts are the molar ratios of the atoms. All right. You can figure out the weight of the individual elements by just multiplying the subscript by the atomic weight of that particular element. That will be the part portion of this. The whole portion is going to be the molecular weight of the particular compound. So I have FeSO4. First thing I'm going to do is I'm going to calculate the molecular weight. I have 1 iron, atomic weight is 55.85. So that gives me 55.85 grams worth of iron. My sulfur is 32.06, so that gives me 32.06 grams of sulfur. My oxygen, I have 4 atoms of oxygen, so that is 4 times 16, or 64. I've added all those up, and so, I add them all up, and it ends up being 151.91 grams. But do I know what my iron contribution is? Mila?
I couldn't even hear what you said. I'm sorry. My kid was just screaming at me.
All right. Do you see the slide on the screen now, Mila?
Yeah, I have it all written down. That's our total weight is the 151.91.
Okay. Do I know what iron's contribution is?
What do you mean, like the 55.85?
55.85. That's iron's contribution.
Okay.
Now, do I know what the whole compound weighs?
Yes.
So how do I get the percentage of iron?
So then you're going to divide the 151.91 by the 55.85.
Either way around.
Either way around.
Part goes on top.
Oh, yeah. Listen, not whining.
So for the iron, I'm going to get 55.85, divide that by 151.91.
And
That gets me 36.77.
Do we always round to the second decimal?
In this case, Mila, I have 4 sig figs.
Okay.
4 sig figs divided by 5. That's why that ended up being 4.
Okay, I'm sorry.
Hayden.
Yes.
Okay, Hayden.
Yeah.
I want you to tell me how to figure out the percentage of sulfur. Tell me what number goes on top and what number goes on bottom.
So the contribution for sulfur is 32.06. So you divide 32.06 by the total weight, the 151.91 multiplied by 100.
Absolutely. So if I do this, I'm going to take my sulfur, which is 32.06, divide that by the molecular weight. This gives me sulfur's composition. And let's say now, Elizabeth, you here yet? Aya, you here yet?
Yes.
Okay, oxygen. How do I get the percentage of oxygen?
You get 4 times 16.00 gram.
Are you looking at the screen, Aya?
Yes.
Okay, what is 4 times 16?
64.00 gram.
So what are you doing with that 64?
I'm gonna times it by 1,000 or 10,000.
Okay, Aya, a percentage is going to be part divided by whole. If my part is the oxygen contribution, what's my whole going to be? Armethea, can you help her? Armethea?
I'm here.
Okay. Armethea, I want to know the percentage of oxygen. Tell me what to do.
You divided 64 by 151.1.
Absolutely. Good work, Amrithia. Aya, the part that's the oxygen are the 4 oxygen atoms. The whole is going to be the 4 oxygen atoms plus the sulfur atom plus the iron. So I'm going to take oxygen's contribution to the molecule's weight, divide that by the whole weight. Are you getting it, Aya?
Yeah, and then you times it by 100.
Then you times it by 100. Okay, now, if my sample weighs 11.24 grams, how much iron, sulfur, and oxygen do you have? Remember, we just used the formula for iron sulfate. We used that formula to determine the percentages of iron, sulfur, and oxygen. Okay, how are we going to determine the weight of iron that we have here? Tori, you just popped up.
Yeah. Wouldn't you take the total weight? So 11.24. No, wait a minute.
Remember, that's the weight of the whole sample. I want to know the weight of just the iron.
Isn't it like what we did earlier with like the 35.6 over 100?
Yep.
Okay, so you would take 36.77 over 100. You can divide those together, but then you take whatever that is times the weight, so 11.24. Hold on, I gotta do math real quick.
Okay, what Victoria has said is she has taken the percentage of iron, turned that into a decimal. So you do that by dividing the percentage by 100.
It'd be around like, if I want to round it to 4 sig figs, I guess it'd be like 4.132 or 4.133.
Okay, so how Victoria came up with that number was she first turned the 36.77% into a decimal, 0.3677, because you got to get rid of the percentage sign. Then all she did was take the decimal of the percentage and multiplied that by the 11.24. Correct, Victoria? Is that what you did? Victoria? Tori?
Hi, hello, yes.
That's what you did, correct?
Yes.
I do that and I get 4.133. My sulfur was 21.10%. I changed that to a decimal and multiplied by the total weight. That gives me 2.372. And my oxygen was 42.13, so I changed that to 0.4213 times 11.24. That gives me this. Now understand, guys, just for kicks and giggles, I could also do it this way. Doing it in this form or doing it in this form, I end up with the same answer. I don't care which way you do it. Either way will work. Okay. I have a solution that contains 45 grams of nickel 2 chloride. How much nickel will electroplate out as solid nickel? Anybody have a solution, guys? You don't have to actually solve it. You just have to give me a strategy how we're going to work this problem.
Wouldn't you have to get the molecular weight of each element first?
And then the total.
And then the total.
Total.
So what am I going to do with the atomic weights of each and the molecular weight?
Multiply them by
Multiply by the subscript.
Well, wouldn't you multiply the subscript that by the 6.02 10 to the 23rd?
No,
If you
Mila.
want to get the moles, that's if you want to get the moles of it.
Okay, my bad.
Nope. Just think, all we're working here are grams. What have we been doing here so far? All we're doing right here, look at the second and the third words of this slide. What have we
You
been
get the
doing?
total mass.
We're going to need to get the total mass of the formula NiCl2. In other words, we're going to need to get the molecular weight of NiCl2, correct?
Yes.
Yes.
All right. So what are we going to do after we get the total weight of NiCl2?
You have to figure out how much nickel will electroplate out as a solid nickel.
Well, how am I going to figure that out?
I don't know. I'm just here for the ride.
This like
Okay, Tori, Tori has a spring break hangover. Mila, what have we been doing, Mila?
was this where we take like, okay, Ni is 1, Cl is 2, and then we multiply that by their atomic weights and then add those together?
That's how you get the molecular weight.
Okay.
Now,
And,
how am I going to get the percentage of nickel?
well, then from there, wouldn't we take its molecular weight of nickel and then divide it by, I'm honestly divided
100?
by the total?
By the total weight, the
total
entire.
mass.
Guys,
Yeah.
time out. Mila has it, although she doesn't know she has it.
Yeah, okay. I'm just not certain.
And you're not using the right terms.
I'm not at
Okay.
all. I'm trying to look at the other problem to like plug in here. That's my way of learning this.
Mila, you had it right. You just didn't know you had it right. You
Yeah,
take the atomic weight of nickel and you divide it by the molecular weight of nickel chloride to get the percent of nickel.
well, would we have to multiply it by 100 afterwards also?
You could,
Like-
yes.
Divide and then multiply by 100 to
Yes.
get the percentage?
Absolutely.
Gotcha, okay.
And so we have in this nickel weighs 58.69. There are 2 chlorines. They each weigh 35.45. So I add all that up, I get 129.59. My percentage of nickel is my atomic mass of nickel divided by the molecular weight. This gives me 45.29%. So basically, guys, this is saying as long as I know what my percentage, what my chemical formula is, I can tell you each and every time the percentage of each element within that chemical formula. So in this particular instance, it's telling me I have 45.29% of nickel, 45.29% of NiCl2 is nickel. If the NiCl2 weighs 45 grams, then 45.29% of that is going to be actually nickel. I take the 45.29, divide that by 100, and multiply it by the total weight. I get 20.38 grams of nickel plated out. Or if you don't like that, you can also do it by saying 45.29 divided by 100 is equal to X over, either way will work. Whichever way you understand better, use that. U.S. Food and Drug Administration recommends that an adult consume less than 2.4 grams of sodium per day.
Wait, I'm sorry, 1 second, Mr. B. For that last question, so I would be able to take 4.4529 and multiply it by the total mass to get my answer?
You would, Curtis, you have to divide it by 100.
You have to get it out of percentage form.
Yeah, or
Yes, so it could be 0.4529
times 45, yes.
times 45. Okay, gotcha. Thank you.
Because 45 is the total weight of your nickel chloride,
Of the nickel, gotcha.
not the nickel chloride,
The entire thing.
the entire thing, yes.
Okay, got it. Thank you.
Anybody else have a question, guys?
Just a quick question. That weight can change. That would be like if you physically like had it in front of you, like that's the weight of what you have in front of you.
Exactly.
Okay.
You took a scoop out.
Okay.
Put the scoop on the balance, and the balance happened to read 45.00 grams.
Okay.
If anyone's having any trouble, this is in our module 8. And it has like all the setups of how to do everything. So if anyone's lost, you can flip to there.
Thank you, Tori. Thank you very much, Tori. U.S. Food and Drug Administration recommends that an adult consume less than 2.4 grams of sodium per day. What mass of sodium chloride can you consume and still be within the guidelines? Okay. Now, the easiest way that you can do this particular problem is doing it by the ratio form, but I'll get in and do the percentage as well. Okay. The thing you have to understand, what is the part and what is the whole in this question? Is the 2.4 the part or is the 2.4 the whole?
The part.
Because it's sodium, the whole is going to be sodium chloride. We know how much weight the sodium is, the part. We don't know how much the weight of the sodium chloride is. Okay? But what we do know is we know that sodium weighs 22.99 grams. The weight of sodium chloride is 22.99 plus 35.45 or 58.44. So all I have to do is put my weight of sodium over the weight of the sodium chloride. This is going to be equal to the weight of sodium, which is the 2.4 grams, over my unknown, which is the weight of my sodium chloride.
Did you just get the weight from a periodic table?
Yes.
Or, okay.
And then you just cross multiply and solve for X.
Correct.
Okay.
As a matter of fact, I go into a little more detail here. Okay. In this particular problem, though, you have to understand I'm not multiplying the 39.33% by the 2.4. The 2.4 is my answer. 39.33% of something equals 2.4. I go through and do the math there. I get 6.2 grams of sodium chloride. Now, guys, we can also calculate parts of an entire molecule as a mass percent. Okay, for example, I can ask what the percent of sulfate there is in iron sulfate. There are compounds out there called hydrates. Hydrates are compounds that have water as part of their chemical structure. It's basically, if you've seen those little packets they throw in shoes, those are what hydrates are. All right. So what you do is you've incorporated water molecules within the crystalline structure of the salt. So if I ask you, calculate the percent of water in barium chloride .2H2O. I just want the mass percent of water. So what is my part going to be here, guys?
Water, H2O.
Part's going to be the water. Curtis, what's the whole going to be?
the entire thing, BaCl 2.2 H2O.
Absolutely. So my water, each water is 2 H's, 2 times 1.01. And my oxygen is going to be 1 times 16. So that gives me 36.04 for my weight of water. My BaCl2 is 1 times barium, which is 137.33, plus 2 times 35.45. This gives me 208.23. So the total weight is the water plus the barium chloride. I get the 36.04 plus the 208.32. That gives me 244.27. Curtis, finish the problem for me.
So we got 244.27, and then we'll take the weight of water. Wait, what do we get for water? Did we get anything?
36.04. Remember.
Okay, so I would divide, would not
water,
divide that.
Each water weighed 18.02, but there were 2 of them.
Gotcha.
So it's 36.04.
So I'll divide that from the 244.27.
Absolutely. You're going to divide the 36.04 by the 244.27. You end up with 14.75%.
Gotcha.
Okay, let's take a break here. I want to hear your commentary. Is this fairly simple so far?
It's not so bad.
Not so bad?
Not yet.
Not yet?
Yeah, it's kind of on par with the other stuff.
Okay.
It's basically the salt and sand mixture lab that we did.
Pretty much. But one of the main things I want you to get from this is the fact if you have a chemical formula, you automatically know what the mass percent is for each one of the elements. Any other questions, guys? Come on, this is the time for you to ask. Okay, we're now going to get into empirical formulas. Remember, as I pointed out to you, the molar ratios of the atoms within the molecule are nothing more than the subscripts. So if we can find the molar ratio of the elements to one another within the molecule, then we can define the moles. Once we find the moles, if we divide by the smallest number of moles, that will automatically give us the ratio of one to the other. So the first step we do when we do an empirical formula problem, find all the elemental weights. From those elemental weights, we're going to determine the number of moles of each atom. Then we're going to divide. We're going to divide the moles of each atom by the one with the smallest number of moles. That will give us the molar ratio of the atoms within the molecule. But we got to look at it. If any one of those numbers is a fraction, we have to get rid of it by multiplying it by an integer. If we multiply it by an integer, we have to multiply each one of those molar ratios by that integer. Compound contains 4.151 grams of aluminum and 3.692 grams of oxygen. Determine the empirical formula. Okay, step 1 was find the weights. Weights are given to us. Step 2, determine the number of moles of each atom. If I have 4.151 grams of aluminum to get the moles, I simply multiply that by 1 mole over the molecular weight. If I have 3.692 grams of oxygen to get moles of oxygen, I multiply that 3.692 grams by 1 mole over 16 grams. This gives me 0.1539 moles of aluminum and 0.2308 moles of oxygen.
And where do we
Next.
find the molecular weight? Is that?
Periodic
on the
table,
periodic
Curtis.
Got it.
Periodic table. Okay. Now,
I'm sorry, is the molecular weight the 26.98 grams, right?
yes.
Okay.
It's whatever 1 mole is equal to, Mila, and 1 mole is equal to the molecular weight of grams of that particular substance. So I have the moles here. Now, my next step tells me I divide each one of the moles by the smallest number of moles. Which one's smallest here, guys? Come on, don't get shy.
Aluminum.
Jennifer?
Aluminum.
The 0.1539 of aluminum.
So I'm going to divide both of those numbers by 0.1539. I do that in the aluminum. I get 1 mole of aluminum. I do it to the oxygen. I get 1.5 moles of oxygen. But has anybody ever seen a molecular formula with a fraction as one of the subscripts? You can't have half an atom. So we have to get rid of the fraction. Okay, the way you get rid of the fraction, you start by multiplying by 2. Okay, 2 times 1.50 equals 3. I have an even number. I don't have to go any further. If I multiply the 1.50 by 2, I also have to multiply the aluminum by 2 because the ratio would not stay the same. 1 to 1.5 is the same ratio as 2 to 3.
Can you go back to the previous slide, please?
So is this basically like, because I feel like we just did this last chapter of balancing compounds and elements and finding the charges and the subscripts. Is this just like the extensive way of finding these out?
Okay. All right. Tori, what if I had iron instead of aluminum? And you have no idea.
Because you don't know what kind of iron it is, right?
Correct.
Okay. Because I was like, I was writing it down. I'm like, wouldn't it just be Al2O3 because that's how you balance them out. But now I understand. Okay.
All right. This is doing it rather than intuitively. This is doing it from experimental data. Does that make sense, Victoria?
Yes.
Can you please explain again? So now we divide, what are we dividing by the small, like?
The next step. The next step in my strategy, Mila, tells you you divide. We figured out the moles of aluminum. We figured out the moles of oxygen. Those are the only 2 elements in this compound.
Okay.
So what I have to do is I have to look at both of those numbers and determine what the smaller one is. Okay?
Which is aluminum.
So I divide both by the smaller number.
Both what?
Both the moles. Okay? I've got the moles of aluminum as 0.1539. So I'm going to divide the 0.1539 by 0.1539 to get 1.
Okay.
I'm going to also divide the 0.2308 moles of oxygen by 0.1539. I do that math, I get 1.5.
Okay.
But I can't leave it like that because I can't have half an atom of oxygen.
Okay.
So I have to get rid of that fraction. The way I do that is I multiply it by 2 to get me 3 oxygens. But if I multiply the oxygen by 2, in order to keep the ratio straight, I also have to multiply the aluminum by 2.
Okay.
So when I do this, I get 2 moles of aluminum and 3 moles of oxygen. So my empirical formula is Al2O3.
Okay, I get that. Thank you. You just went really fast the first time.
Sorry, slow me down like you did. 0.2636 grams of nickel is placed in a crucible and heated in air to form 0.3354 grams of nickel oxide. What is the formula of the nickel oxide? Oh my God. How are we going to do this problem? Oh my God. All right, the first step in my process, find the weights of all the elements. Can we do that? Can we find the weight of the nickel?
Yes. And then
Yes.
Yes.
That's there.
Okay, so that only leaves us with oxygen. Can we
Wouldn't
do that?
wouldn't you subtract the 2.2636 from the 0.3354 since that was what it was at the very end?
Good girl, good girl. Absolutely fantastic. You have to understand, guys, the nickel oxide is only consisting of nickel and oxygen. There's nothing else in there. And yes, you have to make an assumption. You have to make the assumption that all of the 0.2636 was converted to make the nickel oxide. So if you make that assumption, then the 0.3354 is the 0.3354 is the nickel and the oxygen. Of that, 0.2636 is nickel. So if we subtract the two out, we have the weight of our oxygen. Okay, guys, this is where it starts to get tricky. Did you understand what I just did there?
Yes.
Is there anybody confused? I'm hearing crickets, guys. That means either you are so lost you don't even know what to ask as a question, or you're right on. Which is it, guys?
I think we got this part so far.
Okay, so we now have the weights of the nickel and the oxygen. All we got to do is turn it into moles, divide by the smallest number of moles, and use a multiplier if necessary. The weight of the oxygen, I subtract the two out and I get 0.0718. Kaylin, how do I turn this into moles? How do I turn the 0.0718 grams of oxygen into moles of oxygen?
The 0.0718 times 1 mole over the weight of oxygen.
Which is 16. Guys,
Yes.
right now for empirical formulas, we are determining the ratio of atomic oxygen. So we are using, write this down, for empirical formulas, use the atomic weights of the diatomics. That means if you have hydrogen, use 1.01 as opposed to 2.02 for H2. For chlorine, you're going to be using 35.45 as opposed to 71.90. Do we understand? When there's a diatomic, you have a choice between using the atomic or the molecular weight. When you're doing empirical formulas, you are using the atomic weight. So we're dividing the 0.0718 by 16. And we're dividing nickel by its atomic weight of 58.69. So Kaylin, my next step says I divide by the smallest number of moles.
They're the
What
same.
is my ratio between nickel and oxygen?
1 to 1.
1 to 1. I divide 0.00449 by 0.00449. I get 1. I divide 0.0044910 by 0.00449. I get practically 1. So it's a 1 to 1 ratio. So my empirical formula is NiO. Questions, guys? Anything? Another problem. A sample was assayed to give 26.57% potassium, 35.36% chromium, and 38.07% oxygen. What is the empirical formula? Oh my God, oh my God, oh my God. Anybody have a possible solution to this? There's a trick.
We would still have to find the weight, right?
That's the first thing. Absolutely correct, Curtis. That is exactly what we need to do. We need to find the weights of the potassium, chromium, and oxygen.
The atomic weight or molecular weight?
We need to find the weights. The atomic
So,
weights we can look up. But the first step of any of these problems is we need to find the weights of the elements.
So would we take the decimal point 2 places to the left and multiply that by the molecular weight?
We don't, Curtis, we don't know the formula. Right? That's what we're
Yeah.
trying to find out. Anybody?
No, I'm sorry.
Go ahead.
Would we multiply that by the atomic weight then? Or no?
No, it's not going to do anything.
Okay.
We'd have to convert those percentages to
Hey,
grams.
Curtis.
Mm-hmm.
Divided by 100.
One second, Marie, 1 second. You got it, but hold on 1 second. Curtis. You there, Curtis?
Yes, sir, I'm here.
Okay. What you could do is you could say 26.57% of something is equal to potassium's atomic weight. You could do that. Okay. But that would only get you the molecular weight. That would not get you the combination of these elements to get that molecular weight. Does that make sense, Curtis?
Right, that makes sense.
Wouldn't we have to do that
Marie.
individually and add them all together?
I'm sorry, Mila.
Wouldn't we have to do that individually and then add them all together?
Can't do it that way. Maria, what did you say? Maria?
I said divided each percentage by 100.
No, not quite. Somebody pick a number.
Is this the 6.02?
No, it's not the 6. Forget the 6.02. Forget it right now.
Do you get the like find a weight and then multiply the percentage by each weight?
But that's what we're trying to find, Aya. Somebody pick a number. Somebody pick a
20.
number.
Divided by the atomic weight.
26.57.
20. No. Pick a number. Any
100.
What?
100.
1,000.
Okay. If I have 1,000 grams, isn't 265.7 grams of that going to be potassium? Isn't 353.6 grams out of that 1,000 going to be chromium? And isn't 380.7 grams of that 1,000 going to be oxygen? Pick a number. Pick a number.
So the weight for the potassium in this problem would be 26.57 grams. Is that what you're saying?
Absolutely. If you pick a convenient number like 100, then isn't 26.57% of 100 equal to the grams of the potassium you have?
So do we just pick any number?
Curtis, this will work with any number. But trust me, Curtis, you don't want to do extra work, do you?
Right, so we want to pick like 100 or 1,000.
If you pick 100, then you know that of that 100 grams, 26.57 grams of it's going to be potassium.
Right.
Is that 100 going to come into effect later though?
Nope.
How? Like why? I'm just.
Because.
Oh, as long as they're like with the other ones?
Yeah, exactly.
Okay.
We're not changing the percentages.
Okay.
We're not changing the percentages. Any number will work, Mila. When I get done with this problem, take 35 grams and see if it doesn't work.
I like fully get this now. I do get it now. Okay.
So literally speaking, guys, pick any number. 100 is convenient because if you pick 100, all you got to do is drop the percentages, and that's the grams of the individual element. That's going to be the grams you're going to use. Convert those grams into moles, and then all we're going to do is solve it in the same manner. Okay? I'm going to pick 100 grams. So if I have 100 grams, my potassium weighs 26.57 grams. My chromium weighs 35.36. And my oxygen weighs 38.70 grams. Now, what are we going to do here? We now have the weights. What's the next step in my problem solving?
Finding the molecular.
Convert to moles.
Divided by the smallest one.
I got
We
three
divide
different
by the
answers.
molecular weight.
I got three different answers. I got a fourth answer, but the fourth answer and one of these answers is the same.
You would multiply it by 1 mole over the molecular weight of the atom.
That's the fourth, that's the third answer. That is correct, guys. The next step, once we get grams, get yourself into a frame of mind. Once you get grams, next step, convert to moles. And as I think that was that Kayla? Somebody said it correctly. You take
it was me.
Marie? Who was
Christina. Christina.
Okay, thank you, Christina. So you take the weight that you have, multiply it by 1 mole over the atomic weight. That will give you moles. I do that for potassium, I get 0.6800. I do it for my chromium, I get 0.6800. And I do it for my oxygen, I get 2.379 moles. Now, what is the next step?
Divided by the smallest one.
Which is?
0.6800.
800.
Okay, we're going to divide it by the smallest number of moles. And I do this, I get 1 mole of potassium, 1 mole of chromium, and 3.5 moles of oxygen. Now what do I do?
Multiply by 2.
Multiply by 2.
So I multiply each one of those by 2, and I get K2CR2O7, potassium dichromate. Questions, guys? It's a lot of problems. It's a lot of problems, guys. I tried to organize it into this fashion. Okay?
It's a lot to process.
You're right, exactly right, Marie. It is a lot to process. And you know the way you're going to do it? You're going to practice. Guys, I can't emphasize enough. Have I been on you for doing homework up to this point? You're going to have to do the homework here because that's the only way you're going to get these problems down. Another thing that's going to be very important. This last test was multiple choice. The next test will not be. Believe me, you do not want it to be multiple choice. Because if it's multiple choice, I look at the answer, it's okay, it's right, okay, it's wrong. There's no in between. So if I make the question 10 points, you're either going to get 10 points or lose 10 points. However, if I give you a short answer box, and if you show me your work, then I can give you partial credit.
I have a question. This is
Yeah.
kind of like extremely like inconvenient, but is there any way that it could be like written on paper and then like pictured and then put into the box? Because typing it in like really, I have very difficult time doing that.
Yeah, but we can't have our phones open for for honor locked, so that's the
Or
only
just make it
problem.
multiple choice, man. It's all good. I mean, whether we get 10 points or not.
Yeah.
No,
I prefer multiple choice, to be honest, because it just makes
Yeah.
me really freak
this
out.
isn't an option.
I like this way better, but I just have really difficult time.
I
Type,
understand, Mila, I understand. And
If I type it in there and then like on my scratch paper, like after I'm done, this test is submitted, can I like give you my scratch paper to like show you my work on top of what I typed in? Because I feel like when I type it in, it's not getting transcript right.
let me put it to you this way, Mila. Keep your scratch paper. And if there's any dispute,
Okay.
you can submit it at that time, okay? Fair enough?
Yes, I like that option. Thank you.
Okay, guys, this is the end of our time for the day.
Hey, Mr. P, I had a quick question.
I'm here, Curtis.
I wasn't able to finish my quiz today before class because I have work. Would you be able to open that up so I can finish it?
Answers are
right
already
now?
given, Curtis. I can't. How many of you
Oh, man.
missed?
It's probably number 2.
You get to drop 2.
Okay.
All right. I'm sorry, Curtis. The answers are already published.
Okay.
Professor,
I'm here, Tori.
can you talk about that pop quiz
Can I
that's due
talk
on the
about it?
17th? Yeah, like is it just a normal, regular, out of the blue quiz?
No, it's not. It is not a regular quiz. You are going to have 10 short answers to give.
Okay. Okay.
Sorry.
No, I just saw that it popped up and I was like, I wasn't here
Make
in
sure,
the beginning.
everybody make sure the pop quiz is due on Wednesday.
Is it about like what we learned today?
What's that, Hayden?
Is it about like what we learned today?
It could be on anything, Hayden.
Okay.
Omar, do you have a question?
Yeah, you said the public quiz is due on Wednesday. This Wednesday or
This Wednesday.
This one?
This Wednesday.
Yeah, tomorrow.
No, I'm sorry. What did I say? Wednesday, Thursday. I think I put it Thursday. Doesn't matter. Doesn't really matter. It says what? I can change it after
On
this.
it says it's due on Wednesday. It's due on the 17th, so which
Okay.
is tomorrow.
I'll change it to Thursday.
Okay.
If it makes you feel better, Tori, I'll change just for you. If anybody else had asked, I wouldn't do it. It's
appreciate
only
it.
for you.
I appreciate it.
Everybody thank Tori.
Thank you.
Thank you.
Thanks, Tori.
Thank you, Tori.
Remember, a paragraph for each question. Okay, guys, if nobody else has anything, I will see you on Thursday.
Thank you.
See you Thursday.
Take care. Anybody else in here?
All right, Professor. Thank you.
Bye.
Professor,
Bye, Fabiani. Fabiana,
I just have
good.
I just have a quick
I'm glad you
questions.
popped up because you got marked absent.
Yeah, and I was gonna tell you that I said that I was present, but I don't know if you heard me or not.
Did not.
Okay, I just want to make sure.
All right, see you in the lab.
See you in the lab.
All right.
Fabiana, what did you need? Anything? Mila, you're still here.
Yeah, I just have a question, but I want to wait till the other kids are out. I'm
Okay.
sorry.
No. I'm trying to see who else is in here. It's a chat room. Anybody else here? Oh, participant. I got 4 participants in here yet. Chase.
Yeah, I
Okay,
had a question about just grading and
Okay. Go ahead, ask Chase.
I have not done well on both the exams you've given.
Okay.
And I'm just not sure if I should drop or keep going.
How are you doing on the quizzes, Chase?
I was doing good. Now I'm not doing too good. The quizzes it just doesn't seem like they're doing anything. It's just the 2 exams are absolutely killing my grade.
That's kind of what I wanted to stay back and talk to you about too, because I did not do good on those exams. I did the extra credit on exam 2. I'm not sure if I got it right or not. That was really hard to give me some extra points on it. But I know you said you had spoken to me previously about if I don't do good to consider withdrawing it, but I'm just wondering if there's any way that I can't or like not withdraw it because I can't withdraw it due to my financial aid. I'll lose it if I withdraw.
I'll tell you what, guys, give me a call. Are you available to give me a call tomorrow?
Just I have class from 12:30 to 2:45.
I should be available in the morning.
Okay.
Chase?
Yeah. What?
Morning, give me a call.
All right.
Like on your phone or like a Zoom meeting?
Yes, on the phone.
And what's your phone number?
727-202-7275.
What time works for you? I don't want to I'm up early with my kids, so.
9 or later.
Okay, I'll probably do 9:30 then.
That sounds good.
All right.
I don't want to say, basically, unfortunately, this is being recorded as we speak, so I'm sorry, but.
No, it's fine.
No, that works.
I didn't know what you were going to be talking about. We haven't gotten into any specifics, so I think we're okay. Just give me a call tomorrow. Leandre, do you have anything, Leandre?
Well, thank you so much. I'll speak to you in the morning. I hope you feel better.
I'll be fine. I'm going to be fine.
Have a nice night.
Chase, you good? All right, take care, Mila.
Good night.
Good night.